This chapter summary, we're going to look over Leaving Cert higher level statistics. So we're going to break the Leaving Cert higher level statistic into about 9 or 10 parts. The first 5 will be statistics, and then the last 5 we're going to look at the inferential statistics. So the first thing we're going to look at that can be asked is you need to have knowledge of the data type, which is the data canonical or numerical. Sampling techniques. So there are 7 different sampling techniques we would have seen last year, and also then the reliability of the sampling, how example avoided and biased, and so on. The second section of statistics we're going to look at is averages, and there's 2 main averages: the measure of centre, which is the mean, the mode, the median. It's all seen at junior cert, and then the measures of spread, where we had the range, the interquartile range, which was the third quartile take away the first quartile to find out the middle half. We also had percentiles. So if I had data, how would I find out where 80%, the first 80% of the data would lie? And the new idea is the standard deviation. The standard deviation is pretty much the average away from the spread. With regards to the averages and the measures of centre and spread, we also had the analysing of the graph. So the mode is always going to be the highest point of the graph. The median is where you would split the graph 50-50. So if I had half the information would be below, and then the other 50% would be above. And then mean is where it would balance the curve. Not exactly, the median and the mean won't always be the same place, depending on how spread the data is. If it was what we would say symmetrical, the mode would be the same as the median, which would be the same as the mean. But if it is positively skewed, or what we would say skewed to the right, the mode is less than the median and it's less than the mean. And if it was skewed to the left, which is negatively skewed, the mode is greater than the median and the median is greater than the mean. That's the third section. The fourth section, a new idea for the Leaving Cert, is correlation. So it's the relationship between, it's bivariate data. Bivariate data is relationships between 2 sets of data, and we measured finding R, which is a measure of strength. So the closer to 1 that R is, we find R using our calculator. So we need to be able to calculate the correlation and the standard deviation. Make sure you know how to calculate it. If not, send me a message and I can go over a tutorial on that in due course as well. So if it's close to R and it's going up the way, it will be a strong positive correlation. If it wasn't as close to going down in a straight line as we can see in the second, we would describe that as a weak negative correlation. So if it's going up, it's positive. If it's going down, it's negative. And then strong and weak describe the relationship of the strength between the 2 sets of data. And then if we have X's all over the shop, it's not going up or going down, we describe that as no correlation, and we have an R value of 0. And also with your calculators, you need to be able to find the line of best fit. Okay. Then the last thing we're going to look at in statistics, before we look at inferential statistics, is normal distribution and the empirical rule. As you can see, the bell curve, and we have to know the relationship between them. Okay, so just to let you know, the symbol of mu, which is a U with a line down, is the mean, and the O with a line going across is the standard deviation. So what we have is we have an X scale and we have a Z scale. So the mean, what will lie between +1 standard deviation of 1 and -1 standard deviation is 60%, 68% of the whole population. We know 95% lie within 2 standard deviations and 99.7% lie within 3 standard deviations. You need to know what those values represent and to make the connection. That's the empirical rule. The last thing with normal distribution is going from Z scales to an X scale. Z is equal to what you're testing minus the mean divided by the standard deviation. You will need to use both those formulas sometimes to find what any of those 4 unknowns are. Statistics, we're going to look at inferential statistics. This is where we make predictions on the population based on data that we are given. The two main parts of inferential statistics that we look at will be either population proportion, the margin of error for population proportion, or the sample distribution of the mean. We'll also be looking at the p-values as well. So the first one, the margin of error for population proportion, first formula we have is the approximate margin of error, which is E equals 1 over the square root of n. And then the second one we have is the standard error for population proportion, is where p hat is plus or minus 1.96 by the square root of p multiplied by 1 minus p all over n, and that will give us our 95% confidence interval. We generally use the standard error of population proportion unless they ask us for the error approximation, in which we use the first formula. The second part of inferential statistics we will look at is the sample distribution of the mean. And first thing we need to know is we need to understand the central limit theorem and know some of the properties, such as we would use this theorem when there's a large set of numbers where n would generally be greater than 30, or if it says in the question that it follows normal distribution. The second formula you would have had is the confidence interval of the mean, which is p hat plus or minus 1.96 all over the standard deviation over the square root of n. As you can see with both of these formulas, 1.96 would have been your z value to be 95% confident of the value. The last one we're going to look at is the p-value, and the p-value is the region outside a certain confidence interval of minus z and plus z to find out what it would be. So we do 2 multiplied by whatever is greater than the positive z, because we know that the normal distribution curve is symmetrical. Then there are the three inferential statistics. The last thing you have in regards to inferential statistics is hypothesis testing. So this is to test whether something is within a region that we're confident that it's true, or is not in the region. So there's three parts. The first thing you need to do is you need to state the null hypothesis and the alternative hypothesis. Then you have to calculate the test statistic, like what we have looked at earlier on with the margin of error, with the population proportion and the sample distribution. And after we've tested, then we have to write our conclusion. If it is within the confidence interval, we'd say we do not reject the null hypothesis. If it is outside the confidence interval, we will reject the null hypothesis. Notice that we said we do not reject, we never accept the null hypothesis. All we say is we do not reject. So, with regards to three types of inferential statistics we have looked at, we will use p hat plus or minus 1.96 all over the square root of p by 1 minus p all over n. If it's population proportion, if it's confidence interval of the mean, it's a z value between minus 1.96 and plus 1.96. And if it's a p-value hypothesis testing, it's any value that is greater than 0.05.